Hi, good morning and good afternoon, everyone. So it's wonderful to see you all here. Uh, let's get started. There you go. Awesome. So, welcome all to this session. So, here I'll be talking about how do we build AI agents with open source LLMs on watsonx.ai. This is what we will be covering today. Give an introduction about the topic. We'll get into details like what's an LLM agent, journey from LLMs to LLM agents, IBM watsonx.ai and the developer focus we are having, and how to build an LLM agent on watsonx.ai. And I'll give you glimpses of demos, right, on how to build these LLM agents on watsonx.ai. And last 5 minutes, maybe we can take questions. So quick, intro about myself. I'm Vijesh Bhakta Rajgopal. I'm a senior product manager at IBM watsonx.ai. Uh, so what's exciting about my, profile is that I'm at the center of customer requirements, market requirements, what competition is doing, and it's, exciting to be at the middle of, all the action that's happening around AI, right? Trying to ensure that we are building the right features for our developers and for our users and customers, so that we are going in the right direction, right? And empowering all the end users of our product. So usually when I start my presentations, I start with this picture. Uh, uh, if anyone can recall this, so this is a picture from 1956, and it's from the Dartmouth conference of 1956, where the term artificial intelligence was coined for the first time, right? And if you look at the two folks sitting over there, right? So one is John McCarthy and Nathaniel Rochester. Both were IBMers, and since 1956, right, IBM has been at the center of anything related to AI. So we have been pioneers, and we have had several milestones till the day as we speak today, right? So we have our watsonx.ai platform, for you to kind of come and experiment and productionize AI capabilities around generative AI. So one aspect of the Dartmouth conference was that the conference had several workshops, and one of the workshops kind of discussed at length about to have a computer system that emulates how humans take on problems, right? So how humans make decisions through reasonings and the body of knowledge they are exposed to. So this sounds very familiar to in the world of generative AI, right? Where we have LLMs that can kind of reason, that can take decisions, that can plan, activities. So the idea of having such a computer system has been very relevant, right? So for several decades. So the idea is very simple, but however the path we have to had to take, right, to get to an ideal state has been different, right? So today we will look at what is an AI agent, and taking on the idea of what was discussed in the Dartmouth conference, right? And where we are at this moment, right? Are we at a stage where we can say that the technology is perfected, or are we, which stage are we at, right? So we'll discuss on those points, and would be happy to take on questions at the end of the session. So starting with what is an AI agent, right? So AI agent is an intelligent system that uses large language models, right, to perform tasks either autonomously or, of course, we can always have a human in loop, so that the tasks that are mundane in nature can be automated. However, with human foreseeing how the AI agent is performing. So how the AI agent does this is by reasoning and planning what activities needs to be done, right, in order to solve a problem, and not just plan it out, but also perform those tasks, right, by interacting with what is known as tools, or at the end of the day, they are APIs. So how it works, right? So this is the basic flow, right? Let's take an example where I want to meet, let's say, Lynn next week. So I want to book an appointment with her. So I can ask an LLM agent to do this task, right? So by, giving kind of an input, asking the LLM agent to book a meeting with Lynn next week. So the LLM agent is going to understand the input and plan the next steps, right? The next steps could be to check Lynn's availability, check her calendar, send an invite, and get the acceptance, right? So in order to do that, right? So there has to be a set of tools, like, let's say, for example, the calendar API or the email API that can be used, right, to actually execute and setting up a calendar invite. So, what is an LLM agent in depth? So, LLM agent is a program, that whose execution logic is controlled by an LLM, right? So, it is the LLM, the large language model, that decides, how, what are the steps in order to that needs to be taken in a sequential order, so that the task can be completed. So basically, it takes in a user query, and the LLM defines what should be the steps to answer that query with the given suite of available tools, and it kind of iterates on those steps and takes action one after the other, uh, and then build an answer out of that, and provide the answer to the end user. So what makes this very versatile is the accessibility of LLM, or the LLM agent, to a wide variety of tasks that it can do. So so this then kind of can be considered as something closer to how humans react, right? How, let's say, a human would think, you know uh, behind, in your brain, right? What steps needs to be taken, what should be the next step, right? And through a thorough researched reasoning, right? So that's what is making the LLM agents different from what we had a few months back, or earlier, right, a year back. So what we had a year back is an LLM, right? So LLM stands for large language model. It basically understands and generates human-like text, and it is trained on massive, data sets. It comes with different modalities: text, code, images, right? Uh, it comes with different sizes, right? So the latest one, I understand, it's 1.5 trillion parameters, and it can be as small as 135 million or smaller. Uh, it also comes from different organizations. Some are proprietary in nature, and some are open source, like, for example, Llama, IBM's Granite, Mistral. So there are a wide variety of open source, the recent one from DeepSeek as well, right? So these are all open source LLMs that are available. So, so LLM being the core technology that powers an AI agent or an LLM agent. So the question is, can any LLM power an LLM agent? So the answer could be that it's maybe not, right? And are these LLMs a perfect technology, right? So we have been experimenting with LLMs for over 1.5 2 years now, and maybe that you would have realized by now that LLM is not a perfect technology. It has its own drawbacks. So let's look at the journey from a vanilla LLM to a full-fledged LLM agent, right? So when we started with just an LLM, which is trained over huge the data of the internet, right? So huge data sets. So you take in a user query as an input, through zero shot or few shot prompting, the LLM can give you an answer. So that answer is based on what the LLM has been trained on, right? It does not look at any external data. It's only based on what the LLM has seen during its training process. So let's say an LLM being asked a question about a topic that's the LLM does not have not seen during the training process. So the LLM is likely to hallucinate and come up with any creative answer, right, that it can bring out. So similarly, then we realized that it's also relevant to kind of uh, have thorough grounding to facts. And then we had retrieval augmented generation, right? So that again is using an LLM, but however with in addition to that, we have a vector database through which we are actually grounding the user query to relevant facts on enterprise data, or the data that's ingested into the vector database, and then using the LLM to summarize the answer at the end of the day. So this reduced hallucination to a large extent, but again, right? So even vector databases, so these are still technology that has to be, let's say, thoroughly validated, right? So to ensure that it's really performing the way it has to perform. So then came the world of LLM agents, right? So where now instead of using maybe a vector database, so we have a set of tools, and LLM can plan out what and how to utilize those tools, define the steps to answer the query, and maybe in the process kind of reflect or update the steps to take that query and answer it accordingly. So that's where we are right now. Now, all these uh, flavors of LLMs, right? Whether it's vanilla LLM or a RAG or an LLM agent, has its own problems at hand, right? So the LLMs can hallucinate, there can be bias, there can be data privacy issues, there can be prompt sensitivity, as in uh, slight variation of the prompt itself can and alter the output answer, right? So there could be issues with outdated knowledge, with which the LLM is trained on. There can be n number of issues, right? So that can potentially create an issue, right? That can either alter the answer, or can kind of even hallucinate tools, right? So it can maybe call a different tool a wrong tool, right? So wherein by which the answer is corrupted. So before we start working with these technology, so one thing that we need to be very uh, you know uh, knowledgeable about is that these technologies are not yet perfected. So hence that it has to have a proper governance process around it. There has to be thorough tracing mechanisms and observability put in place to ensure that the LLM agents or any generative AI technology that we are using is following what we intend for it to do, right? So a thorough observability is absolutely required to kind of build LLM agents for enterprise, or for at scale, that are going to cater to maybe thousands or millions of users at the end of the day. So the risks of LLMs, while it still lives, along with the agents, it is amplified through agents, because in this case, agents are going to reflect, it's going to plan. So the LLMs are probably going to be, inferenced multiple times. So there are more touch points where things can go wrong, right? So this is kind of a document. I encourage everyone to go through this document to kind of understand what are the risks that are involved, right? And how are we planning to mitigate those, and or how you can plan to mitigate these AI agent risks, right? So this is coming from the IBM AI ethics board, a very interesting read for everyone to kind of go through. All right. So we've heard about assistants, right? So when we think about agents, we first think of assistants, right? So there is a co-pilot, or there is an assistant, there is a chat box where you can chat with, right? And uh, the bot, or the assistant is going to help you through the process, and finally solve your problems, or answer your queries, or complete a task which you are planning to do, right? So traditional assistants are rule based, with predefined action paths, and with agents, right? So let's say if we start with a single agent, it's going to be still task based, but however, the LLM that is running behind under the hood is planning out, what needs to be done, right? Similarly, as we go ahead, right, as we tackle more and more complex use cases, like for example, if you want to build a travel agent, or let's say if you want to have a specialized agent, like let's say flight booker, right? So here the agent is going to interact with multiple tools, and also multiple ways to think through how to solve a problem, right? So then there has to be multiple agents that have to collaborate each other, and then try to solve a problem. So we have gone from traditional assistants, and in the future, which we're seeing is from single agents to multi-agent assistants. So which one you want to choose will all depend on the use case which you're trying to solve. Uh, if you are a beginner, I would always recommend to start with single agent assistant to kind of tackle a single task, and then gradually with more once you're confident about its performance, you can experiment on multi agents, and start building multiple multi agent assistants. So basically, the AI, as we see today, is changing rapidly. From with LLMs, we saw an AI that can create something for you, that can generate text or image or video. With assistants era, we had AIs that could chat with you, right, and solve a problem or fulfill a task. And now with AI agents era, we are going to see AI that can not just create for you or chat for you, it can also do things for you in real, right, using the API economy in place. So from a value creation perspective, we are at a tipping point where there are several areas where we can look at, and the future seems to be very bright, let's say for AI agents, right, because it's going to influence more and more use cases, more and more industries, right? And we are going to see enterprises, companies, organizations start picking up AI agents and take it through the development cycle, and all through production, right? So we are going to see that in the next 1 to 2 years. And it's estimated that 1/3 of AI interactions by the end of 2028 is going to be Gen AI, and through autonomous agents, right? So this is from Gartner, and this paints a very positive picture, and about the technology in itself, that where customers, or let's say organizations, have started seeing a tremendous ROI in these technologies. So AI agents are going to unlock the next wave of productivity gains for an enterprise or for any organization. So excited to be living at this moment, right, where we can see and kind of start building AI agents and see how it's going to solve and increase productivity for everyone. So coming to the topic of how to start thinking about building an LLM agent, right? So of course there are many jobs to be done, right? So when you're approaching a use case, right, so you have to first define what you want to build, what is the agent use case. You need to have a detailed workflow, and most importantly, you need to align whatever you are working on, right? So it has to align with the final business goal. So planning is as important as building and let's say deploying. So so with planning, you need to identify what tools are you are going to use, what are the appropriate models that you can use to build your AI agents, what frameworks and libraries would you like to use, right? And what are the underlying infrastructure to optimize from a cost effectiveness perspective, right? So design is a very important aspect. When it comes to build and deploy, it's all about experimenting with and integrating with an agentic workflow, with an LLM inference provider, right? You using the right tools to build it, simulate various behaviors which you would probably are likely to see in production. Ensure that the guardrails are in place so that your LLMs are not hallucinating. Your actions, the outputs are aligned to what your expectations are, right? And at the end of the day, you have to take it into a production environment and ensure that it's working at scale, right? And you're monitoring all the logs, and to ensure that all the KPIs are tracked and aligned, thereby bringing kind of a transparency and explainability to what you have built, to ensure that the AI agent is working as per your what you have envisioned. So the first step is very specific to how do we build a LLM agents, is to select an LLM, right? So there are three things on a very high level that you need to be looking into while selecting an LLM. So first is its ability to reason and plan, right? So chain of thought is a concept where an LLM can decompose your user goals. Let's say if you want to book an airline ticket, it has to understand that requirement and plan it out, right? Step by step. How are you going to act on it? So actionable steps through reasoning has to be done. So your LLM has to have good reasoning capabilities. The second is ability for your LLM to uh, perform function calling or tool calling, right? So here an LLM is not actually calling a tool, it's like trying to understand or generate a text with which an orchestrator can understand that, and say that, hey, LLM is now asking you to call an API, and this is the payload structure, right? So this is a signature of the API. So this is very important. Let's say when you are building an LLM agent, to pick an LLM that has very good uh, function calling capability. The third is ability to follow instructions, right? So let's say, for example, when a user is asking it to book airline ticket, right? For example, it should uh, precisely understand what the user is asking, and let's say if there is a set of instructions given by the end user, it has to follow the and understand the instructions and precisely follow them, right? So all these areas are evolving, right? So none of these are let's say a technology that is uh, absolutely working perfectly fine, right? And these areas are evolving as well with every new model versions. This these areas are getting optimized. There are better ways by which these can be done. There are better models, right, that can perform these three areas precisely. So in addition to that, there are several other aspects which you need to be considering, right? One is like ability to have a good memory context, let's say longer context length, right? It's not a must have, because you can still build some memory using uh, let's say a vector database for that matter. Once you start building it for a purpose, right? Like if you want to solve a problem and you have a large amount of users, right? Large volume of users. So you need to be looking at whether the LLMs are performant, they're fast with let's say low latency. uh, if you are tackling any specific industry area, right? So you need to ensure that the LLMs are can be customizable, right? Let's say you can fine tune it to a specific task, for example. So and in addition to that, you need to ensure that the LLMs are cost effective. At the end of the day, it has to be economical. You need to be bringing the cost down while you still have some good value to bring onto the table. uh, and of course other areas, like let's say depending on your use case, whether it has to support multimodality, and how sensitive are your end users or the industry which you are serving, right? So you need to have those safety filters and guardrails in place. So the LLM has to support all these capabilities, right? So this is step number one. So on watsonx.ai, we have two versions, right? So for to build agents. So one is a no code version. So what we are calling it as Agent Lab. So on Agent Lab, we have several models that are supported out of the box. And when it comes to a pro code user experience, we are calling it as Developer Hub, where users can come, get onto our Developer Hub and start building and get access to APIs and templates. So there are no limits, right? So you can pick any foundation model of your choice, right? That handles chat tasks, that supports function calling and tool calling, right? And that can choose the next action, right? Uh, spoke about instruction understanding. So yeah, this is what is supported today on watsonx.ai. Step two would be to select the right architecture, right? So I've just picked two for today. One is function calling, right? So definitely you need to, it should be pretty straight. I mean, can work for pretty straightforward use cases, right? Where you want to have, I mean, you have a query and a simple plan, and you need to act by using a single, let's say, tool, right? So it could be a RAG application, right? Agentic RAG, for example. The second is, let's say, reasoning and acting, what is known as React, and this is one of the most popular frameworks that are available today, and which watsonx.ai also supports, right, on Agent Lab. So this is kind of inspired by the way humans intuitively use natural language, right? So given it's like, let's say if I want to travel to Singapore, for example, right? So I'll think in my mind, right? How can I do that, right? So what is the best way to navigate to Singapore, right? Should I, you know, travel by ship or an airline, right? So how should I reach the airport? So similarly, right? So there is an iterative way by which a plan is created, and there is an observe. We are observing it and we are critiquing on our first plan, and then we are reiterating on that, right? So React is one of the primary architecture. So finally, right, so when you select an architecture, it all depends on your use case, right? And how complex the architecture should be to kind of ensure that, use case, you're doing justification to the simple or complex use case which you're trying to handle. So when it comes to watsonx.ai, on Agent Lab, we have React. And while it comes to developers, a pro code experience, right? You are free to build on any architecture of choice, right? So backend is architecture agnostic, while Agent Lab is a no code UX, right? So we are gradually, still in beta, and we are gradually bringing more and more architecture going forward. It's there in our roadmap. The third step is selecting a framework, right? So this is debatable, right? So when we compare different frameworks, uh, it's not an easy task to pick a framework, right? But again, it's your nature of the use case that will drive you, and what kind of problems you're solving, right? So whether you are solving it for a very large enterprise, right, use case, or is it for a hobby, right? So it would all depend on how you are, or what is the purpose of and your use case, right? So for example, you need to pick a framework that has very good observability if you are uh, planning to solve a use case for a large enterprise, right? So because we have to look at auditability of what the agent is performing, and it has to be logged, and it has to be available for reporting, as well as course corrections as we move from one version to another. And also look at it from a perspective of what tools are available, right? So it's not an easy task, but picking the right framework is a task in itself, right? And that needs to be carefully, meticulously taken into consideration. So when it comes to .ai, watsonx.ai, on Agent Lab we support LangGraph, while again on the developer hub you can pick and choose any framework of your choice, and we also provide a lot of templates, right? So we have templates built for Llama Index, LangGraph, AutoGen, Crew AI, and B framework, right? Where you can pick the template. We've created one example for each, and you can just pick it up and make corrections and take it forward in your development cycle. So, talking about watsonx.ai, right? So, .ai is our next generation enterprise studio for AI builders to train, validate, tune, and deploy generative AI, right? And AI agents is one capability that we have on board, right? So, we have a huge AI toolings that are available for data scientists and uh, AI builders. So and these are focused on three core themes, right? So when I say core themes, this is what enables our end users, developers, to love our platform, right? So first is flexibility and choice, right? So we ensure that the data scientists, the AI builders have a wide range of tools and frameworks that are available to them at their disposal, so that they can experiment, they can build anything using any framework of their choice. The second is simplicity, right? So we are not only catering to data scientists or AI builders or developers for that matter, it could also be business users. Uh, so, uh, so I was talking to a customer recently where their end users are actually doctors, right? So they are medical practitioners who don't have any coding experience. So we, at watsonx.ai, we ensure that we have user experiences that are both available for pro code users, developers, AI engineers, while we also cater to some of our users who are not, uh, you know, uh, good at coding, let's say. The third is innovation, right? So innovation is that provides data scientists and AI builders, latest models, tools, right? So let's say when you're talking about AI agents, right, MCP is being discussed very extensively, right? So IBM Research has also come up with a framework called, ACP, right? So you should be reading about that. So innovations, something that we are heavily focused on, right, to ensure that we bring in the latest and the greatest to be available for our end users. Perfect. So let's look at flexibility and choice, right? Uh, if you look at the whole stack, right? So right from the bottom, we ensure that we provide our end users with a hybrid cloud platform, not sticking to any specific cloud. Uh, we are a hybrid cloud technology provider, and we support different types of GPUs, like for example, from NVIDIA, AMD, and Intel. We ensure that we have runtimes for all use cases, for all generative AI use cases, and predictive and prescriptive analytics as well, right? And as we move up this stack, we ensure that we have a secure platform where multiple AI builders can come together and build you know uh, the whatever you're building, right, the AI assets, the data assets, collaboratively in a secure environment. So in addition to that, right, with AI models, we support a wide varieties of let's say open source models, right, from IBM's Granite models, from Mixtral, Meta's Llama. In addition to that, you can bring in any model from Hugging Face, right, using our custom model import capability, where you can pick and choose your favorite model that is a best fit for your use case, and we support what is known as bring your own model or custom model import, where you can import your favorite model and start using it. We provide a lot of flexibility and choice when it comes to data science and machine learning and generative AI tools, right, starting with ways by which you can customize your models with agents, instruct lab, RAG, fine tuning, prompt tuning, right? So we have a wide varieties of AI tooling that allows you to customize models at low cost. We support tons of libraries and frameworks. You can choose and pick any one which you want, right? So that is custom fit for your use case. And you know all the tools and integrations that needs to be made available for your AI use case. We support data ingestion, synthetic data generation, right? Guardrails to protect your AI use case from hallucinating or deviating from any policies. We have a very strong deployment and tracing capabilities, so that whatever you're deploying is well monitored, right? We have a very thorough governance process uh, through which you can take your AI use case from an idea phase all the way to production, right? Ensure that your models are meticulously and properly governed. So that's about flexibility and choice. And so this is one example of flexibility and choice, right? Let's say that you're building an AI agent. We support the end-to-end agent lifecycle, the agent ops, as we call it, right from the model support to model customization, the various agentic frameworks that are supported. We support multiple tools, and with watsonx orchestrate we have another 1500 plus built-in skills. We bring in a lot of deployment choices out there, and we are working on something known as tracing, and you'll be hearing that very soon, in a month's time, about how we are going to support and have all those capabilities to kind of ensure that we have a very flexible end-to-end agent lifecycle platform in place for everyone to experiment on. Talking about simplicity, right? So different user experiences we have, for example, specific to AI agents, we have Agent Lab, which is a click-through user interface, no code absolutely required to build an AI agent. At the same time, we have the developer hub, and you can bring your own IDEs to start working on. We have SDKs and APIs that are made available for developers to start working on an AI agent use case. So yeah, so Agent Lab is an example of kind of a simple UI for to build AI agents. Uh, all it requires is a couple of clicks, right? So talking about IBM research, they bring in a whole variety of innovations, right from the platform level, the silicon level, right? So they have come up with Spire, which is an AI accelerator, can perform it at par with GPUs. Uh, IBM research has been, ensuring that we have efficient runtimes, right? So that can uh, run models at extremely, let's say, cost-effective way. The most important part of IBM research is AI models in itself, right? So with Granite, we bring in mixture of expert models, multimodalities, right, and with with very rich reasoning capabilities that can be used for building AI agents. So on the DSML, the tools, right, the AI tools perspective, also the B framework is one of the recent innovations, and you would soon be like, hearing about ACP, which is very similar to MCP, the protocol for agent to agent communication. Uh, yeah, and just want to bring your attention to Granite 3.3 Instruct, right? So where, so this is a latest state of art model we have from IBM Research, and it's available on Hugging Face. It's also available on watsonx.ai. I encourage you to use this. uh, Primarily because to build AI agents, it has extended context length, it has superior function calling, reasoning, and RAG capabilities. Its chain of thought is amazing, right? And it also comes with fill in the middle, right? So it kind of helps to improve reasoning clarity, especially when it comes to code completion, right? So I encourage everyone to use Granite 3.3 models as you are experiencing the Tech Exchange Dev Day. uh, yeah, that's what I would like to say. All right. So we spoke about assistance, right? Where we had a chat box somewhere, at the right hand side bottom corner, where which you can invoke the chat bot and start interacting with it like a co-pilot. But with AI agents, you're looking at a software engineering agent, right? Which is built, which is deployed on top of a GitHub issue, right? So you don't see an interface where you have a different user experience for where an AI agent would appear and try to solve your problem. So the AI agent is uh, you know stitched into the GitHub experience itself, right, where it is going to look at an issue, it is going to plan out how to resolve that issue and then create a PR, right? So this is what we are going to kind of experience as we move forward building AI agents, where you can build experiences right into your uh, uh, you know uh, product capabilities, right? So uh, powered by open LLMs that are available, and extremely ease of use, right? So look at the let's say, I mean, this wouldn't be imaginable a few months back, where an AI agent is kind of solving your GitHub issue, right? And writing code for you or whatever, right? So making corrections. So this is we have seen an impressive kind of 24% success rate over here, right? and this is going to be the let's say user interface, or this is going to be the way AI agents will be built into your existing product experiences. Of course, when you build a new product out of using AI agents, it's a different case, but this is something which is extremely impressive. And looking at our customers, right, so we have seen multiple customer stories out there, different use cases, from customer experience to digital labor to procurement to IT operations. uh, Across even within IBM itself, we have seen almost $3 billion being saved by marketing, supply chain, and IT operations uh, by deploying AI agents, right? So extremely, this is a powerful technology for to unlock productivity, and uh, and extremely positive about this for the near future. Talking about watsonx.ai, so Agent Lab is, as I mentioned, right, it's a uh, is a no code interface where you can select the tools which you want to use. There are several capabilities that are built into it. You can select a framework, you can select the architecture by just selecting a drop down, and the agent is built in the background, right? You can preview the agent, and you can see details about how agent got to an answer, the step by step, so how the planning is done. You can look at the full tracing details right onto the UI, right? So this is extremely useful for a user who's probably not that great uh, with coding, or might want to kind of build an agent. So this is still in beta, but very powerful tool that's we are building. So in addition to this, right, so you can see a deploy button on the top. So it's extremely easy to kind of deploy the model with just one click, right? So it would automatically be uh, deployed to a deployment space, and from which you can start using the endpoint that gets created as part of that. So when it comes to pro coders, right, so we have developer hub, and for agents, we bring in a list of foundation models and templates that you can start using. Like for example here, right, so just to give you a highlight, right, so in order to start using it, you need to have a project ID, a space ID, and API key created on. So you need to create an account in watsonx.ai, and you can start using your, let's say, a VS Code IDs by importing the template. You can download it from developer hub and start looking at the agent, right? And you can make corrections, you can make changes to it, you can decide what tools that it has to use, right? So all on a pro code interface, right, so of your choice. So in this case, it's an arxiv AI research agent, which is using DuckDuckGo search engine to kind of you know summarize an arxiv paper, right? For example, you can use the terminal to use maybe initiate and ask a question, right? uh, for example, right, so if you want to know more about Granite models, you can uh, search, right, find a list of papers on Granite models. So it's going to understand the user's input and get the details and summarize it for you. So this is one example. You will find several examples that are available on Developer Hub. I encourage everyone to you know go to the Developer Hub and explore the options that are available to build an AI agent. So very easy, right? Like quick 5 steps there. And from the perspective of deploying the agents, you can let's say, I'll just go there quickly. All right. So you can deploy the agent in a deployment space. You can create the deployment space. It comes with an ID, and you can deploy the agent which you have built as an AI service on IBM Cloud, and you can see that deployment by navigating to the product on the watsonx.ai interface. Go to the deployments, and you can see the details there. So it creates with just a few clicks, right? So, and private endpoint and a public endpoint, and you can also preview it, and you can start interacting with the uh, AI agent right in there, right? So extremely powerful. Okay. Perfect. So here are some additional resources which you can go through, read about. So definitely Developer Hub is a very good starting point. Encourage you to navigate to the Developer Hub and get started with your new AI agent development. So, and then we have API documentation that's available. You can read more about our Granite models. You can create a free trial on watsonx.ai and start using it as well. So, pretty excited to be here talking about our AI agent and Open LLM capabilities on watsonx.ai, and uh, yeah, have great time coding and building AI agents on watsonx.ai. Thank you. All right, so maybe we can take some questions before we wrap up for the day. Just looking at the questions that are available. So the first question, right? So is it possible to use several LLMs in an agent, each suitable for a subtask, right? So the answer is yes, right? So you can create, let's say for example, if you are creating a multi-agent, you can explore ways by which you can use several LLMs in an agent. So one thing you need to be probably also cautious about is the cost. So when you know if it's something very demanding for your use case, absolutely I would support that. But when it comes to agents, it consumes LLM tokens like never before, right? Unlike a single LLM. So let's say if you are putting multiple LLMs in place, so it is likely to consume a lot of tokens. So that you need to be aware about and see how you can optimize it. So why the LLM are not first separated to embedders and generative one, and then to how to generate to divide themselves? I'm not able to understand that question. So, but so maybe I'll go to the next one. So how do you see the role of persistence while building an AI agent? Right. So persistent, as in, if I understood it correctly, if you're talking about memory, uh, there are ways by which, if that is the question, right? What do you want to retain, right, from a conversation? Let's say, for example, in a session, or do you still want to recollect something that the agent has performed, right, for a new session, right? So probably you might have to build something, some a vector database maybe for kind of a memory for that particular user. Yeah, why not? It's a possibility. So can watsonx.ai be run locally in a data center? Yes, right. So we support hybrid cloud. You can decide, where you want to deploy watsonx.ai. It can run uh, on an on-premise environment, right? So it's possible. The answer is yes. So is orchestrate also a tool to build AI agents? Absolutely, right? Uh, so this is how we are positioning watsonx.orchestrate versus watsonx.ai. So orchestrate has its own capabilities, right? So it has its own strengths, and what orchestrate is going to consume watsonx.ai under the hoods, right? So for the AI capabilities. So that is the synergy between watsonx.orchestrate. But if you want to build let's say a vertical AI agent, right? So of course you can build it on watsonx.orchestrate also. But finally, it is going to use watsonx.ai capabilities under the hood. So how long can we use the no code version for trial? So trial is for, I think it's for 1 month, and it has limited token utilization of around 50,000. So yeah, you can use it for a month or so, right? And for every month you will get 50,000 of token usage. So that's like one month and 50,000 token. Where can I learn about B framework? Of course, you can just Google it. There are like a lot of details available on the IBM website around B framework. You can look at the documentation as well. How do you take an LLM from watsonx.ai and put it on Z17 to use the Spire and Telia? So excellent question, right? So we are working on that. So to begin with, right? So we have done announcement to support Watson Code Assistant and Watson Assistant for Z on Z17, and that will run on Spire, right? So that the LLMs that are going to power the Watson Code Assistant and Watson Assistant will run on the Spire, uh, uh, AI accelerator, and it is likely to be GA'd by end of this year. Can an agent action update database or create file? Absolutely, right? So an agent can create, can take any action, right? Provided you have the relevant tools. Let's say if you want to update or do, let's say, a CRUD operation on a database, right? So agent can accordingly take that call and make the call to uh, uh, use an API to make that updates on a database. Absolutely, yes. Or create a file to a path. That's possible. So what GPU specifications are required to run IBM Watson X on-prem? So it depends on the foundation model which you are planning to deploy. So we support H100s, L40s, and A100s at this moment, and we are soon going to support a variety of Intel and AMD GPUs as well. So you can always go and read the documentation. Maybe I can guide you to like through those links maybe, or you can just search for on-premise documentation. It gives a wonderful guide on how to select GPUs based on your foundation model specifications. All right, did I miss any question? So, are there any recommended open source models that performs well in Arabic? Right. So for Arabic, we had partnered with the Saudi Arabia organization over there. It's called Alam, if I'm naming it correctly. So Alam models can be made available on .ai, right? So that's available. So Open Pages, how does Open Pages provide governance in watsonx.ai? So if the question is very specific to AI agents, right? So we are working on that to ensure that there is thorough evaluation in place for not just evaluation from the perspective that during the dev cycle we need to be evaluating the models, the AI agent in itself. In addition to that, from a monitoring, health monitoring perspective also, right? So this is something which we are working on. We are calling it as tracing, and it would soon be announced in Think event that's going to happen in May, and soon it will be GA for general usage. Yeah, awesome. Thanks everyone. It was nice interacting with you. Hope you enjoy the other sessions. Thank you.